Very good morning to one and all. This is Kevin from Kongunadu College of Engineering and Technology. Today we can see about the topic of what are the properties of fluid. First of all, density. Density is known as mass per unit volume. The notation of density is rho and the formula is m by v. SI unit is kilogram per meter cube but also used gram per centimeter cube. Specific gravity. Ratio of density to the density of the water at 4 degrees Celsius. Density of water at 4 degrees Celsius is 1 gram per centimeter cube. The 4 degrees Celsius is important since water density changes with temperature. It has nothing to do with gravity. Relative density would be the better term. Pressure. The static fluid will exert a force perpendicular to the any surface it is in contact with. Pressure is defined as the force per unit area. Note this is a scalar unit. The SI unit is Newton per meter square, Pascal, bar. These are the units of pressure. Next, atmospheric pressure. The big volume of air above us expert pressure downwards. Pressure at sea level is 1 atmosphere. That is 1.013 into 10 to the power of 5 Pascal. It changes depending upon the elevation, temperature, weather condition, etc. How will the pressure act at depth? Assume that rho is constant all throughout the liquid. Fluid is incompressible. So, force is from weight of a liquid. So, pressure is equal to force by area. Force is equal to mass into gravity. Mass into gravity. Mass is equal to density into volume. Therefore, volume is equal to area into height. So, the pressure is equal to rho hg. Pressure at depth. If fluid is incompressible, density changes with height and the equation is only valid for very thin slices. Pascal's law. The Pascal's law deals that the pressure acting at the liquid in the all direction or should be constant. The equation is independent of area, only height matters. Pressure is the same at any 2 points at the same level of the fluid. If the pressure is applied to the one end, it is distributed throughout the fluid and to the walls of the container. Pascal's law application. Hydraulic lift. In the hydraulic lift, you can see the F1 force is applied downwards. How much force we will give in the small amount of area, the forces, the pressure will transmitted all over the liquid. In the other side, the car will move easily. So we have give the small amount of pressure, it will change into the large amount of pressure in the all sides of the liquid. So the formula is P is equal to F1 by A1 is equal to F2 by A2. However, volume of the liquid remains the same. V1 is equal to V2. Hydraulic lift, it is also the same procedure. F1 by F2 is equal to A1 by A2 is equal to delta x2 by delta x1, that is displacement. Work done by F1 is equal to work done by F2 are same. A car lift used in a service station uses compressed air to exert a force on a small piston with a circular cross section of radius 5 cm. The pressure is transmitted by a liquid to a second piston of radius 15 cm. What is the force must compressed in the air exert to the lift of the car weighing 13,300 Newton? What is the air pressure produces this force? This is the example of the Pascal's law. We can see the formula. P is equal to F1 by A1 is equal to F2 by A2. F1 is equal to A1 by A2 is equal to F2. A1 is equal to pi r1 square divided by pi r2 square. Because it is a cylindrical object, the area is pi r square into F2. 5 square by 15 square is equal to 13,300. So F1 is equal to 4,480 Newton. Therefore, pressure is equal to 1,88,000 Pascal. Note, no need to convert the units. Absolute pressure and gauge pressure. Absolute pressure, total pressure within a vessel. Gauge pressure, excess pressure above the atmospheric pressure. Gauge pressure, best example, a tire shows on 220 kilopascal. Absolute pressure is 220 kilopascal plus 1 atmosphere is equal to 320 kilopascal. Flat tire is actually have 1 atmospheric of pressure inside. Pressure gauge is measured by the device called manometer. Many different devices are used to measure the pressure. Manometer is first what we can see. Manometer consists of an U-shaped tube filled with a liquid is known of known density is shown in the figure. It is open in one end and the other end is connected to a container filled with a gas whose pressure is to be measured. The pressure gauge, the bottom tube has the same pressure. So we have measured the pressure of the U tube with the known liquid is P plus rho into G into Y1. Y1 is the height of the liquid. P atmosphere, that is we do not know the P atmosphere. So rho into G into Y2. Y2 is the tube liquid height. So P minus P ATM is equal to rho G. Y2 minus Y1 is the height of the liquids in the both the tube. Difference in the height of the liquids. So H. Gauge pressure is proportional to the height difference. Pressure gauges. Barometer is a device. Mercury barometer consists of a filled tube of mercury closed on one end and the other end is inverted into a dish of mercury. Pressure is closed end of the tube can be approximated to be 0. P ATM is equal to rho GH plus P naught. ATM is equal to rho GH. Its unit is mm Hg. Hg means mercury, or torr is another common unit to measure the pressure. It is affected when it is affected by the temperature. Buoyancy. A body is immersed in a water will weigh less. Buoyant force is exerting an upward force. Assume a submerged object with uniform cross-section area. Buoyancy is equal to Fb minus Ft. B is equal to Pba minus Pta. A is common area. So pressure in buoyancy minus pressure in the tube. So rho GHB minus rho GHT. A rho G into H. So buoyancy is equal to rho Vg or mass into gravitational. Buoyancy is works on the principle of Archimedes principle. In that only the weight of in the ship the weight had been happened, but it does not immerse in the liquid when the weight of the ship is increased. When a body is immersed in a fluid, the fluid exerts an upward force on the body equal to the weight of the fluid displaced by the body. Example, Archimedes was tasked to determine if the crown of a king was pure gold. He solved this first by weighing the crown in air and then weighing the crown when submerged into water. Suppose the scale is 7.84 Newton in air and then water is 6.84 Newton. What is the crown made of? So we have been solved. Summation of force is equal to 0. 0 is equal to force is T1 minus mg. So T1 is equal to mg. 0 is equal to T2 plus buoyancy minus mg. T2 is equal to mg minus buoyancy. So T1 minus T2 is equal to buoyancy. Buoyancy is rho into V into G. Rho of water. We know the density of water, velocity into G. So 7.84 minus 6.84 is 1. Density of water into velocity into gravity. V is equal to 1 by rho W into G. So the velocity is volume is 1.02 into 10 to the power of minus 4 meter cube. So the now we can determine the liquid used density. So rho C is equal to mc by volume 7.84 divided by 1.02 into 10 to the power of minus 4 is the volume into 9.8. So the density of the gold is 19,300 kilogram per meter cube. Buoyancy. An object will float if the buoyancy is greater than the weight of the object. So rho density is greater than density of the object. Fluid flow. Complicated but can be simplified with certain assumptions. Ideal fluid flow. Incompressible, same density throughout. Not viscous, has no internal friction. Minimum turbulence. Fluid flow. Assume the fluid flow. The flow rate is constant. Rho into area into velocity is common for inlet and the outlet. So A1 into V1 is equal to A2 into V2. This is simply known as continuity equation. Also area into velocity is the discharge of the water. Example, a water hose of 2.50 centimeter diameter is used by a gardener to fill a 30-liter bucket. The gardener notes that it takes 1 minute to fill the bucket. A nozzle with an opening of cross-section area 0.5 centimeter square is attached and held. So water is projected horizontally from a point meter above ground. Over what horizontal distance can be water be projected? Flow is equal to A1 into V1. So 30 liter per minute is equal to 0.0005 meter cube per second. So AV is equal to 0.005 meter cube per second. So velocity is converted. Then the velocity can be find out is 10 meter per second. So velocity is 10 meter per second. The y is equal to minus half into gt square. Then the time taken is 0.45 seconds. Then the r, distance covered, is velocity into time. So 10 into 0.45 is equal to 0.4 meter, the distance covered. Next, Bernoulli's equation. Pressure in a fluid depends upon the velocity and the height. Assuming ideal fluid at certain cross section will do work on the other parts. W1 is equal to F1 d1, W2 is equal to minus F2 d2. Finally, we can find in the Bernoulli's equation half rho v1 square minus p1 is equal to rho g y1 is equal to half rho v2 square plus p2 into rho g y2 square. Example, water enters a house through a pipe with an inside diameter of 2 cm at an absolute pressure of 4 into 10 to the power of 5 Pascal. A 1 cm diameter pipe leads to the second floor of the bathroom 5 meter above, and the flow speed at the inlet pipe is 1.5 meter per second. Find the flow speed of the pressure and volume flow in the bathroom. Example is solved by continuity equation and Bernoulli's equation. We can find the equation pressure is equal to 3.34 into 10 to the power of 5 Pascal. Then the flow is calculated 4.7 into 10 to the power of minus 4 meter cube per second. That's all. Thank you. We can see in the next class.